This is Mission Control Houston. Welcome to today's ISS Update. It is Tuesday, January 15th, 2013. This is a live view inside the space station flight control room here at the Johnson Space Center. This team here today is being led by Flight Director Matt Abbott. He is sitting there at the center console. Sitting beside him is Capcom Clay Anderson, veteran astronaut. He is the voice up to the crew and will be serving as such throughout the remainder of today in this Orbit 2 shift. The Expedition 34 crew on board the space station has a busy day today. Kevin Ford, the commander of the crew, has been working on an experiment called Elite today. This takes a look at the connection between brain visualization and motion while the crew is up on board the space station. Obviously, your motor skills and how you react to things is a little bit different up in space than it is here on Earth. So what they do is they set up a camera and record in 3 dimensions the motion of the crew members and how they react going through this type of experiment. They even take a look at how crew members would catch a baseball or something like that up on orbit, because as it happens, our brains are extremely wired to deal with gravity, and even though the crew members know that they're up in space, their brains sometimes still process things as if gravity still had an effect on things. So what they do is they study this, and hopefully will lead to better ergonomics and better spacecraft design in the future. So Kevin Ford will continue to work on that for the next couple of hours. Oleg Novitsky has been busy this morning working in the Russian segment on a crystal experiment that exists there. He is also going to be working on the immuno experiment, which takes a look at how stress and long-duration spaceflight affect the immune system and different pharmacological ways of dealing with that. Evgeny Tarelkin himself has also been busy in the Russian segment. He has been taking some air samples, which is done periodically. They also take some surface samples as well, just to make sure that the air and the surfaces that the astronauts and cosmonauts touch and interact with are clean and acceptable. He's also going to be working later on this afternoon on the station's inventory management system. This is a fairly extensive system that keeps track of where everything is on board the space station. It is quite a large complex, and making sure that the crew members know and the ground teams know where everything is important. Chris Hadfield has been working with Tom Marshburn this morning on the iServe. This is a new experiment on board the space station that they are in the process of setting up. This is an automated system that is designed to capture images of the Earth's surface from on board the space station. It is primarily a means to gain experience and expertise in automated data acquisition, something that the crew members don't interact with, but is just automatically up and running. But it is expected to provide some fairly unique and useful images of the ground below for disaster monitoring and assessment, and also environmental issues down on the planet below. But what they're doing is setting up the Window Observational Research Facility, or WARF, which is a rack inside the Destiny laboratory. They're going to be installing a 9.25-inch telescope there in that window to point it down at the window below. And there's also a digital camera that is set up with that telescope, and then that experiment will be up and running. It's due to run for about 3 to 6 weeks, just depending on the weather patterns down on the Earth below. Obviously, they need some clear skies to capture images of the planet down below. But there should be about 60 individual data acquisition takes of this iServe experiment over the coming weeks. Marshburn himself has also been working inside the laboratory on some routine maintenance on the combustion integrated rack. This is one of the fire experiments on board the space station. The crew members periodically have to basically plug in some more fuel tanks and clean up the different pieces that make up that combustion integrated rack. So he is taking care of that today. And also beginning later on this afternoon, after we're off the air, activities will continue on the robotic refueling mission, or RRM. That activity began yesterday, will continue throughout the week. It is out there on the far right-hand side of the station's truss structure. And ground teams both here and at the Canadian Space Agency have been putting the Dexter robot along with the station's robotic arm through the paces. What this RRM does is it's about the size of a washing machine, and there's different tasks and different attachments there on the end of that. Dexter goes up there and pretends like it's servicing a satellite far out in orbit. It snips some wires, it removes some caps, and later on this week it is going to be actually injecting some simulated fuel there into that RRM practice facility that's out there outside the station. This is an important task for the space station to prove can be done, because whenever you launch a satellite, that satellite is limited by how long the parts are up and running and operational and healthy, and also how much fuel is on board. The majority of satellites don't have the ability to be serviced or refueled, but this RRM experiment is proving that that can be done as far out as 22,000 miles out away from Earth's orbit. And finally, today, a reboost of the station is planned for Wednesday night. That'll be tomorrow at 8:15 p.m. Central Time. This will be a 3-minute, 45-second firing of the station's Progress 49 thrusters. That is the cargo craft that is on the Russian segment of the station right now. And that will increase the station's orbit by 1 statute mile. This is setting up for the next Progress resupply ship that is coming up in February. That'll be the Progress 50, and it should be attempting a single launch today, docking with the International Space Station, arriving at the complex on the same day that it launches. The reboost should leave the station at an altitude of about 262.7 by 247.8 statute miles.